Hi, welcome, Jamie Tosawa and others. What we have is a study circle, and Jamie, can you go to the first? Is this yours? Uh,
Yeah, it is. This one is mine.
yeah, okay. Let me stop sharing, and or you go to the first. And does it include the last one, new one?
No, no, it will not. But let me
So
just quickly.
okay. So what you do is you stop sharing. I'll start on mine and then I'll switch it to you. Okay? Yeah,
Okay.
yeah. Okay. Uh, did I share? No, not yet, right? Let me share. While you are there, let me share. Hey. So I'm sharing my screen. Uh,
Okay.
so, okay. So what we have is, okay, okay.
So I can do one thing. I can share it because I updated. I opened
Okay,
the
okay.
updated one.
I'm stopping sharing. You share it.
Okay.
So here we are. Can you make sure that it is full screen?
Yeah.
Right. Hi everyone. Uh, Welcome to machine learning. This is the AIML Study Circle, and I have today's presenter is Jaimit Wasawa, and we are at Baroda or Vadodara, what we call. And I have Jaimit Wasawa and we are recording. So because this is a short notice, we are beginning here. I'll explain before Jaimit can tell you about the introduction to machine learning. So first, we have a group of folks who work together and produce content content for the AIML study circle. So the study circle involves people coming together, studying on their own, and guided by the people who are around, like we have in our uh, eOTF Emerging Open Tech Foundation, which is eOTF, it is called, and you have a eotf.info is the web, the eotf.in. .in is the website. Under AIML, you will find we have several experts, which includes uh, what you call the Sanyam Pathak, who is one of those, and Vivek Hariharan. These are the two experts who are part of this, who guide us. Besides that, we have other Professor Gokhale, myself, Prakash. We are the founders, or co-founders of the organization called Emerging OTF. Today, I am at Baroda, and we have a MS University 78 batch, which is associated with this. And I must recognize what you call Madam, who is responsible, who is the professor of computer science, and she is one of the people who is helping us at the MS University. And we have a website. We have a what you call the meetup site where we have posted this called AIML Study Circle Introduction. And just let me share that before I let me stop share on Jamit and show you this so that you are aware of what we are talking, and then we can go ahead. So here is my share of the screen, and which is AIML Study Circle. Okay. So what you are seeing is We have AIML Study Circle. This is hosted by eOTF, Emerging Open Tech Forum or Foundation, we call it. And we are starting, this is December 29th, 6 p.m. we started. We just wanted to introduce everybody. So AI and machine learning and deep learning, these are all terms that are very common these days. And to train machine to behave like human is the task of professionals like us who are in the AIML. And there are many aspects. We have data scientists, we have data engineers, and they are computer professionals and subject matter experts in the vertical domain. They work together to provide AI-based solution. Now, as you see, the AIML Study Circle is sponsored by Emerging Open Tech Foundation, eOTF, and together, like-minded people of youth who lead and teach, learn and teach collaboratively. We kickstart with a launch today at MSU Vadodara 78 batch alumni meeting we have tomorrow, and this this is to encourage all the people to and students and entrepreneurs to lay foundation for their future endeavors. And so, as I said earlier, I wanted to ensure that we have proper course detail, and this study circle will evolve. We have not fixed any fixed course. All we have done is we have the link to connect every Friday 6 to 7:30 p.m. and we will discuss about the ML system design, and this will be 8 week, and those who are able to uh, go through the records as well as attend and give some exam, they will be awarded the certificate. So Jamie is our first promoter of this. So he has taken up the honors to present. Now, so as you are aware, we are a what you call a meetup group. At the same time, we do have several leaders in this. There are some dozens of leaders, and Mamta madam, who I mentioned, Mamta Padole, she is the professor at MS University. She is one of those who is organizing, and other students from MS University will join from the uh, January, because this is we have given a short notice. This is just to record what the course content will be, and introduction by Jamie will help us in absorbing what is need to be done as part of the study circle. I think with that, I will also say that those who register and those who want to certify will have to give an exam at the end of it every Friday. If you can attend 75% of it, you will be qualified for the certificate. But at the same time, you have to pass the uh, assignments that will be given to you. And mostly we'll be doing use case studies, and that's what we want to handle. So I am stopping sharing here, and I will hand over now to Jaimit to go through and complete the today's recording with the introduction which I have given. That should suffice. Yeah, go ahead. Jaimit, share your screen. Yeah, make it bigger. Yeah, good. You can start.
Okay. Thanks a lot for introduction uh, to Prakash sir, and
And
thanks a lot for your TF.
Jayamit, I forgot to introduce. Yeah, he's an engineer and he has been here 4 years in this area for working on various IT related stuff. And he's one of those who has volunteered to go with the machine learning. Yeah, go ahead, Jayamit. Sorry.
Okay. Thank you. Thanks a lot, Prakash sir, for introducing me. Hello all. Welcome to the machine learning introductory uh, presentation. Uh, I will be discussing few steps on what kind of questions must be presented to before answering or before designing a system.
Yeah, Jayamit, one sec.
Hello,
Chintan is there. Just acknowledge Chintan. Hey, Chintan, welcome.
Hello, good evening.
hello,
How are you, Jaymeet? Welcome.
hello, hello,
Hello,
sir. How
Prakash
are you?
sir.
Yeah.
I'm good.
Chintan, welcome.
I'm
Yeah,
good.
go ahead. Let him handle.
Yeah,
We
yeah.
just gave
Please,
the
please, please
introduction.
carry on. Yeah, yeah, please carry on. Please carry on. Yeah, yeah, yeah. I'm done.
Okay, thank you. So So this is only an introductory machine learning presentation. We'll be discussing about the steps before designing a system, and we'll be going through uh, most of them as we can fit in an introductory class. So first we'll start with AIML. AI are really common terms that are discussed nowadays as for the likes of ChatGPTs too. Uh, but a lot has been going on, and the studies were being taken place since years and years. And platforms like ChatGPTs are result of such uh, studies that have been taken place since years. So, what is actually AI? It is the ability for the computer to think and act like human. But saying that is a really simple and it's a really generalized definition. But a computer needs to train and learn on different data sets, and depending on the what kind of task it is trained on. When we train a model with data sets to learn a specific task and learn it efficiently, and this is termed as ML. But when we want to teach a model to learn really complex tasks, we go for deep learning. Deep learning being a subset of machine learning, where you use complex aggregate learning methods and networks to enable machines. What deep learning does is it uses various processing layers and passes the data through these layers and gives us a really complex and a detailed output of the data. Below is a Venn diagram that shows the relationship between AIML and DL. Now, let's discuss the steps before designing a system. So, clarifying requirements, framing the problem as an ML task, data preparation, model development, evaluation, development and serving, monitoring and infrastructure. These are some of the common steps and that one might need to before and before designing a system. Of course, the use cases of the system can vary, and hence these systems can make it flexible, but this can work as a good framework before designing a system. And for the sake of easy understanding, I have also divided these steps into design, development, and deployment steps. As we'll go on further in the presentation, we'll discuss those. So clarifying requirements. This is the first point in design while designing the system, is to know about the requirements the system should have. So, first is business objective. Business objective is the reason to why are we building, or how are we working with the existing system. What is the reason behind to build a system? Features the system needs or supports. Do we if let's say it's a video posting website, do we need a like and dislike button, or do are we depending on the user feedback for the trending post or the more likable post? Such are the features that the system needs to have and should be discussed while designing the system. Data, how the data is collected, from where it is collected, what is the authenticity of it, are some of the points and that should be known while discussing the data part. Constraints. Constraints is the what kind of uh, limitations are we having while designing the system, or what kind of let's say a resource allocation do we have when we build a system. we can't have a system with unlimited memory and CPUs or GPUs to work with. So we have to know prior before designing a system that what kind of resources are we having in hand and what kind of resources we will be allocating to the system for different processes. Scale of the system means the scalability of the system with time. As the model works, different kind of data with time are to change, and more data comes, and with that, the system should be able to scale well with time and should be properly maintained and optimized as performance. As discussed before, the way data changes and the way user behavior changes and the performance of the system should also kept in check in order to keep the system relevant with time. Going on to the next step is framing as an ML task. So the So having a business objective, have and clear and having a clear and good idea about it, a good understanding about it, gives us a good way to translate the business objective into an ML objective. Not every business objective is necessarily an ML objective. So let's say uh, we are having a video posting website where the business objective can be to increase the user engagement by 20%, but that does not translate to a good ML objective. But what we can do is take good steps or take good ML steps to translate those business objective into ML objective, like having more user engagement, more user engagement post to the user, which are trending more and more, uh, and being more capable of predicting the user's behavior on what might make the user engage more on the platform. Spe- Specifying the system's input output, and the way we will uh, define the ML objective, we will also have to define the way we will introduce input and output to the system. uh, Input to the system, like for example, you can see in the first figure on the left hand side, we have a harmful content detection system, where the post is the input and the output is the probability whether the post is harmful or not. The- in the similar way, we can also have users interaction and the and an event. In the second figure on the right hand side, you can see event registration scenario, where in scenario one, the user's interaction with the model gives us a various number of probabilities, where the user is more likely to register for the event. In the second scenario, you can see the user and the event that is registered, both are matched in the model and the probability of it is given. So in scenario one, user itself is giving the as the input, while in scenario two, user's input and event, both of them are being the input and giving us the probability. Going on to the next step, choosing the right ML category. As as ML, so most of the time, the way ML objective is defined also is also an ML category. So discussing the ML categories, we have supervised learning. So just quickly rewind a bit. ML category, the way we are dealing with the way we are building the system and the way we and the kind of data that we have, we know the most of the ML objective as also falls into the ML category. So if we have image processing, we have such ML categories which where it will directly fall into the ML category. So going on to the ML categories, supervised learning, where a predefined output is known and the model is trained with data sets until it gives us the desired output. Unsupervised learning, where and let's just first discuss the supervised learning fully. So classification is uh, classifying the from the data, classifying the, let's say, image. So if you want, so if we are classifying the image in whether the it contains a particular object or not, we we have binary. But if you are classifying that there are multiple objects in the image, and we are trying to identify a lot of them, then we have multi-class. So binary can have does the post contain a dog in it or not, but the multi-class can have does the post contain dog or a cat or a different kind of animal or not. Regression regression is helpful when we are trying to predict a continuous value. For example, the house price or average user height in a college or stuff. The, in unsupervised learning, the model is uh, uh, the the data is processed by the model, and there is no correct path to it. The model itself gives us the results. There is no right or wrong to the part, and we do not know what kind of output we will get. So in unsupervised learning, we'll discuss clustering. Clustering is a grouping of similar kind of data points into one similar group. Uh, Going on to the association, association is dependency of one data point on another. So let's say for shopping, we can have bread and milk together, but we cannot have bread or screws together. So we have two different kind of association, and bread and milk goes hand in hand. The same is dimensionality reduction. It is also a technique to reduce uh, the complexities of a data set, and helps a machine learning model work efficiently with less data while also preserving the uh, original data sets image. In reinforced learning, we have uh, in reinforced learning, the ML model learns from trial and error method. Like for example, a house cleaning robot. It can eventually learn by uh, keep on avoiding the obstacles, or by colliding slightly with the obstacles, and learn the whole path to the room or house. Going on to the next steps is data preparation. So data preparation is collecting data to feed it to the model. So in the let's go figure wise. Data sources data source from data source is from where the data is collected. It is an important part to know from where the data is collected, as it answers many questions like who collected the data, the cleanliness of the data, authenticity of the data, whether the data is user generated or is system generated, and the way and the collected data is then engineered further. Let's discuss that. So, data engineering is a practice of building pipeline to collect, store, retrieve, and process data. As the data is collected in raw form, it has to be transformed into usable form by the to feed it into the machine learning model. So so after data engineering further, the data set is also engineered or configured further to feed it to the ML system. So feature engineering is the addition and construction of additional variables or features to your data set to improve machine learning and model performance and accuracy. The most effective feature engineering is based on sound knowledge of the business problem and your available data sources. the the quality of the features that we can extract from the data set also reflects on the quality of the output that the data model will give us. So spending a good time on feature engineering or in data in general can be a worthwhile thing to do. Going to the next slide. Data storage or database is a data repository to persistently storing and managing collections of data. Different databases are built to satisfy different use cases. Below in the figure, you can see for SQL and NoSQL databases and their relative uses, uh, the relative management softwares or uses, useful softwares. Going on to the next one. ETL. ETL is a really common process of extracting data from various data sources, transferring the data into a usable format, and loading the data into database or warehouse lakes and etc. for the use. As uh, as we store data uh, in the database, there are different types of there are different data types. So data types in ML can differ from programming data types like string, float, int, etc. So mostly can be classified as below. So so in we have structured and unstructured. In structured data type, we have numerical where numbers are used to represent the data. So we have discrete and continuous. Discrete data types are unique values which can be used to identify data, whereas continuous is the kind of data which where the measurement is needed, like wind speed, uh, average height of a person, etc. In categorical data, the data is normally categorized, where in categorical ordinal is o- ordinal ordinal is similar to a grading system where you can group the numbers together and to form a to to represent to represent it with an alphabet. In nominal, we have data like name, address, marital status, gender, etc. For unstructured data, we have audio, video, image, and text, which are really hugely common common types of data that we are familiar with. So here are the some of the common models for structured data: decision trees, linear models, SVM, Bayes bias, KNN, etc. So as we are dealing with the data, we also need to have the data to be data set to be really efficient for the model to work with. So we'll discuss a few types where data can depending on the type depending on the use, we can also have a simple way to work with the data. So discretization or bucketing is a process of making the continuous feature into a categorical feature. Helps model learn few categories rather than learning whole infinite number of possibilities. So what this is helpful for is we do not have the model to learn each an individual way, but rather have them grouped and learn it in a single manner, in a single step. Going on to the integer encoding is assigning an integer value to a unique category value. So, for the sake of understanding, we can also compare the figure of integer encoding to the grading system. But here we have assigned an integer value rather than an alphabet. So we'll discuss one hot encoding in a small, just a small way. That one hot encoding is where a binary value is created for each unique value. But what one encoding can do is it can also create many vectors for a model to deal with. So it has to be known where we are exactly using it. So depending on uh, as discussed, the points discussed before, we have an ML system. uh, we have the components in the ML. We'll keep a track of components that we'll keep in an ML system. So after discussing the data, we have a data collection where verification, feature extraction, and configuration is discussed and should be done. We will keep on filling this diagram with the components that we will have. So in entering into the development field, we have model development, which is to building, selecting, and training the model. Uh, so where- so after discussing the business objective, translating it to an ML objective, and then working with the data, we need to know depending on the data that we are working with and the kind of output that we want, we have to select the most efficient algorithm that we can work with. While the data is while the model is processing the data, the processes uh, are to be done in particular manner. So process management tools are used to monitor over the process of um, for managing the process, and analysis tools are used to analyze the output given by the ML algorithm. Going on to the evaluation, evaluation is using different metrics to evaluate models performance. Evaluation while in the development phase, we have to uh, train and test the data, and test the ML model with the data set, and whether the ML model is not being getting prone to overfitting or underfitting. Overfitting is just too much familiarization with the data set, where the model is not capable of identifying its another similar kind of data, and underfitting is just really normal or inefficient way of recognizing the data, where the efficiency of the model is not as per the requirement. Though evaluation is being discussed in the development phase, it is also an important part of the deployment phase of the model. Going on to the next slide. So after discussing the data and ML model, uh, we have these two components in our ML system. Steps in the deployment phase, we have development and serving. which refers to continuing to update the model to keep it relevant with time and serving the users with more updated features and uses. So though the also stated before shortly was that as the model is deployed, the more and more data has to be handled by the model, and how the model model adapts the changes and changing behavior of the user and the amount of data increase. The model has to be maintained with time, as discussed before, in the scalability of the model, and serving the users with extra features, and serving the users and having a good look on the behavior that is changed with time by the users can also help us develop the system. So what we can also do is we serve new features to the users, and depending on the interactions with the users we can have a good feedback on what kind of development do we need in, in developing the system. So it's a really healthy cycle to have, and which helps us maintain the system. Going on to the monitoring and infrastructure. After deployment, monitoring the model and keeping the infrastructure maintained are important processes. Monitoring is a really big big point to discuss, and it contains a lot of uh, it it contains it depends on what the company needs, how the company wants to monitor it. And though let's discuss briefly. um, from knowing the kind of input that we want to the kind of output that we get, we have to monitor each and every process, and each and every component are working in desired manner. Monitoring is also to know whether which kind of data can cause the system or the model to crash or stop working, and if in that case, do we have a, a failure detection system or not? If we do have it, and can we back it up or not? Back up uh, the data or not? Similarly, infrastructure helps us operate and maintain the whole ML system, and keeps it running smoothly. So having a good infrastructure and keeping it optimized, or updating it with time, gives us a smooth operation of the whole system. Yeah. So let's see the components that we have now. So for the ML system, we can have this as a basic points to work with while building a system. So data collection, ML model, and monitoring and infrastructure. Process and resource management is also a point that monitoring has it, as it also has to monitor the resources that are allocated to the different components in the ML system, and different kind of memory consumed while the processing is being done. So optimizing the process and the model helps us to be efficient with the resources that we have. So let's also go discuss a bit of ML system outline.
Yeah, speak.
Hello,
Yeah,
am
go
I
ahead.
audible?
Yeah, you are audible. The screen may not be there. That's okay. You can continue. So, what is
Okay,
the? Yeah.
okay. So this is what similarly a system outline should look like when we are trying to design a system. These are the components, and we have discussed the steps before designing a system. So data collection, data verification, and feature extraction can be grouped together within the data part of the system. ML algorithm, process management tools, analysis tools and evaluation pipeline can be grouped together for ML algorithm. Monitoring, resource management, and infrastructure, and also the configuration should be grouped together with the data as well. So sorry, I forgot to mention that. So uh, th- uh, so this was my presentation. Thanks a lot for listening, and I'll hand it to the speakers. Give it to the speakers. Thank you.
Hey, thanks, Jaymeet. Let's ask Chintan. Chintan, what do you think? This is the outline for what we want to do for every use case. What's your feedback? Any feedback on this? Yeah, go ahead. Chintan, are you there? Yeah, maybe he's. That's okay. So what we can do is we will take this and go from here. I think we have done at least introduction recording. Let me check if Chintan is there. Chintan, can you uh, comment before unmute? Let me see whether I can mute. Chintan, are you there? Yeah, looks like he's not unmutable. Okay, no problem. So what we do is at this time we will stop the recording here. And thank you, Jamit, for presenting a realistic outline of the framework that is required for AIML, as well the processes involved and the system. So ML system design, starting with uh, uh, business case, and why is the system needs to be changed, or if it doesn't exist, why to build one for ML, and accordingly follow the process from the requirement up to the delivery of the inference or whatever the case may be. And that's what you ran through based on the data, the resources, the various pipelines. And so it was a real good one. And we will try in the next some use case which you can bring, and or if somebody can speak about the use case, how to apply this ML system design for a given use case, that will be our goal. And we will try do this several use cases so that each one can bring a use case and help us understand how to go about it. I think with that, I will try to end the call today. And thank you very much. We have spent around 50 minutes or so, 50, 55 minutes. Few minutes, first 10 minutes, actually, so 45 minutes was good enough for this time. And we don't have anybody, we have just recorded enough for us to launch it. And from the next Friday, we will be doing on a regular basis. Then we'll also have a Q&A at the end of. So January 4 weeks, February 4 weeks, 8 Fridays, and then that way we'll useful ones. And with that, I will end the call today. I am going to stop the recording, and welcome to the recording, and we'll share this with everybody in the community for the study circle. And thank you very much. Let me stop this first.